Okay, so in this lesson, we're going to look at how we can figure out what the correct type of graph is for a set of data. And then we're also going to look at what are known as marginal and conditional distributions. So let's take a look at this first set of data here. Here we have data that shows the types of radio stations. You know, we have all these different types: country, adult contemporary, rock. We have two different tables showing them though. So like, even though the format is exactly the same in both tables, the right column that shows these numbers are different. This one shows count of stations, this one shows percent of stations. And so even though they are both quantitative tables, these numbers represent something different than these numbers. These numbers, when we say count, represent just how many there are. Like there's 1,556 adult contemporary stations. There's 869 rock stations. There's a total of 13,838 stations. Whereas this table shows the percent that each type of station makes up of the total. So for adult contemporary, they make up 11.2% of all the stations. The rock stations make up 6.3%, and so forth. So depending on what you're trying to figure out, well, like what types of questions you want to answer in regards to some, set of data, one set of values may be better than the other. So we call this a frequency table. We call this a relative frequency table. So when you hear relative frequency table, think percent. When you see frequency, just think about counts, like the way you normally count. Now, when you make a relative frequency table, or any table for that matter, make sure that the data all adds up correctly. So in this case, since we're doing percentages, the percentages should add up to 100. However, you can see it adds up to 99.9. Now, that's just because each percent is rounded to the nearest tenth. So it makes sense that it won't add up to 100. So just be aware of that. Make sure you understand that. Okay, now you probably understand most people don't like to look at data when you have a bunch of numbers. It's usually intimidating for a lot of people, and it can be overwhelming. And when you try to do like a business presentation to somebody, they want it's the easiest, simplest way. So what we like to do is create some sort of like diagram, like a bar graph or a pie chart, something that is very easy for people to read. We can even use colors and stuff like that. So we're going to look at those types of graphs next. Okay, so here we have some data that tells you the percent of teenagers from 12 to 17-year-olds, from 12 to 17, that posted this type of personal info on their social media profile. This is taken from the data in 2012. So if you want to make a graph that shows this, the way you're going to go about this is you're going to have a different bar for each type of information. You're not going to make them all into one bar. So we would have one bar for photo, another for school name, city, and so forth. And the height of each bar will be percent. And we'll go by equal increments to make sure that it's very easy to relate how much the quantity of one group relates to the quantity of another group. So let me just zoom ahead. All right, I already have the answer written here to save some time. So your graph should look something like this. So you have the photo going up to 91%, school going up to 71, city 71, since they're the same, email 53, and cell phone 20%. Now the follow-up question, would it make sense to make a pie chart for these data? So in other words, would it make sense to put all this data into one, circle graph? I'll think about this for a minute. And the question you want to ask is, does it make sense for all these groups to be part of a single entity, to be part of a single group? I guess you want to see is another way to think of it. And in this case, it wouldn't make sense because each percent refers to a different type of information. They all don't make up a single whole. So it's like, don't think of it as like maybe you had a pie chart that represents, the the type of hair color you have, whether it's, black, blue, purple or something. Since you can't have two hair colors, so to speak, let's say everyone can only have one, it would be okay to put data like that in a pie chart. But in this case, it's possible that the same individuals have their photo and school on their profile, or they have the photo and school and city. So then it would be like double counting or triple counting each one. So it wouldn't make sense to put it in a pie chart. Now, that being said, when you make a chart, whether it be pie chart or any type of graph, you want to make sure that it makes sense quantitatively speaking and like in the proportionally speaking. So when we're talking about a graph like this, it's about the heights that we want to compare. The heights should make sense. You should make it so that this difference, this 21, is the same as, a 21 down here or 21 here. See every unit of 10 or every 10 percent is the equal height. Well, that's what you essentially want to make sure that your graph isn't misleading, so to speak. And that's because, you can actually throw people off, confuse them if you make them different sizes, because people will just simply look at a graph, and from there they're going to react to how much they think something is. So it's also important to make sure it's equal widths as well. That being said, let's look at this other problem where we have a misleading graph. Here we have these two basketballs that represent the number of assists and the number of steals that Dwayne Wade made during the 2008-2009 season. Now, these assists represent, they average 7.5. This should be 7.5. And the steals are 2.2. Now, here's the thing. Even though the heights make sense, the 5 is, half as high as the 10. And, in this case, the 7.5 is a little more than 3 times the height of the 2.2 steals. When you look at the size, when you look at the width of this graph, or this bar, you can say, for this basketball, is much wider than the width of this one. So even though 7.5 is only a little more than 3 times 2.2, the size of this basketball is maybe 1, 2, 3, 4, probably 6 or 7 times the size of this basketball. So it over dramatizes the difference between the amount of steals and the amount of assists. So this is not a good graph. You want to make them either both be this wide or both be this wide and make it, a good graph. Okay, so let's go over our next concept now. So we're going to go over what's known as marginal distributions. So it has a weird, kind of confusing definition. It says that a marginal distribution of one of the categorical variables in a two-way table of the counts is the distribution of values of that variable among all individuals described at the table. Okay, so I know it sounds confusing, but you all probably have used this or read, data with marginal distributions. So all that means is like a subgroup. And we say marginal because the data or the groups are broken down along the margins. So let's go through an example problem to make this very clear. So here we have a set of data that represents a random sample of 2024 adult cell phone owners. And it breaks it down by their age group and the type of cell phone they own. So what we're going to do is calculate the marginal distribution in percents of type of cell phone. So it's exactly what you would think. You want to see what percent of everybody own an iPhone, what percent of everybody own an Android, what percent of everybody own another type of cell phone. So let's do each group at one at a time. So for the iPhone, what you would do to figure out the marginal distribution of iPhone is you figure out the total people that own an iPhone, which is this number, and divided by the overall total, the total I like to say. So 467 by 224. And you're going to get approximately 0.2307 or 23.07%. Now for Android, you would look at the total number of Android owners, which is given here, 503, and then divide that by the overall total. So 503 divided by 224. And that will give us approximately 0.2485 or 24.85%. And then for the other type of cell phone owners, we would take their total, which is 1,054, and divide it by the 2,024. And that would give us about 0.5208 or 52.08%. So now we just graph these values as the heights in the graph, and then when we have like our three groups, iPhone, Android, and other on the horizontal axis. So we could have iPhone, Android, and other. Again, we like to, it may probably make sense to, you only need to scale it by 5 here because nothing really goes above 50. So scaling by 5. And that would be our percent. And then we just draw a corresponding bar up to the matching percent for each group. So for the iPhone, we draw a bar that goes up to something like here. About 23%. Android, 24.85, so a little bit before 25. Something like that. And the other would be about 52.08. So that'll be our highest one. So about up here. Now, side note, in statistics, it's really not too big of a deal what you round to in like a lot of the problems. Don't worry if you just put 23% or 23.1%. The problems are designed where they're not really testing that. So don't stress about like, oh, what exactly we stress, what exactly should you round to, or like why didn't you go to like the hundreds place or 10,000th place or whatever. It's not a big deal with that. Okay, now let's look at a conditional distribution. So here's a formal definition. A conditional distribution of a variable describes the values of that variable among individuals who have a specific value of another variable. There's a separate conditional distribution for each value of the other variable. Now again, it sounds a little confusing, but all that means is like a subgroup of a marginal distribution. So like it's like let's say like what percent of boys play basketball or something. The condition is that there has to be a boy. If you're not just asking what percent of people play basketball or percent of boys and girls, you're saying percent of boys. You go further, what percent of 13-year-old boys, that sort of thing. What percent of boys in algebra 2 play basketball, and that sort of thing. So here we're asked to find the conditional distribution of cell phone type for the 18 to 34-year-olds. So the condition is that they have to be 18 to 34. So we only care about these individuals. So the way you want to think of it is just forget that the rest exist. Only these people exist because they're the only ones that are 18 to 34. So we're going to find the same three types of calculations, except we're only going to look at the total for the 18 to 34-year-olds. So for the iPhone, we look at the total iPhone users in this group, which is 169, and divided by the total in that group, which is 517. For the Android, we would do the total in that group, which is 214, and divided by the 517. And for the other, it would just be the 134 divided by the 517. So let's go ahead, let's just calculate those, and I already did them here. So this would give you about 32.69%. Here you would get about 41.39%. And here you would get 25.92%. Okay, so now what we need to understand in statistics is that you're not going to be, given problems straight up that tell you like to calculate this or calculate that. That's really like an algebra question. In statistics, you're the one who has to figure out what makes sense to calculate. So when you're studying data, ask real life questions. Like something to ask would be like, what might cause one variable to change the other one? Like what variable is responsible for changes in the other one? Is there a relationship or something like that? Or we could say an association. So if we're dealing with like that cell phone data, a general question you may get, and this is something that you want to keep in mind on your AP exam, because free response questions will come in something like this form. It won't be in the form that we just saw. It'll say, based on the cell phone data, is there evidence of a difference in the distribution of cell phone ownership for the three age groups? So like the way you want to think about this is basically saying, is there a relationship between, age and the type of cell phone they own? Like the different age groups tend to own different types of cell phones at a different, percentage. Or so then think of this like, let's think of it like this. Does your age have a relationship with the type of cell phone you own? Okay, so what you essentially want to do then is to calculate the conditional distribution for each age group. Now going back to it, we already did the conditional distribution for the 18 to 34-year-olds. So we're going to do this for the other age groups, for the 35 through 54-year-olds and then the 55 and older groups. So let's break that down. So let's look at the 35 to 54. And then we'll look at the 55 plus. And for each one, we're going to look at the iPhone, the Android, and the other. Okay, so going back to the data, we look at the total for the 35 to 54-year-olds. There's 637. So again, we only care about this column. We don't care about the rest. we take these three numbers and divide each of them by 637. So the first one will be 171 over 637 for the iPhone. We know the other ones will still be over 637, so let me write them right now. And for the Androids, it'll be 189, and the other will be 277. And let me go ahead, let me calculate those percentages. All right, so for this one, we would get about 26.84%. Here we would get about 29.67%. And for this one, we would get about 43.49%. Okay, so now let's look at the 55 plus age group. So we, again, now in this case, we only care about this column. And so we're going to divide each value by 870. So for the iPhone, it'd be 127 over 870. Let me just write the other ones over 870 right now. So the Android would be 100 over 870, and the other would be 643 over 870. And let me just convert these to approximate percentages now. This is 14.6. This we would get 11.49. And here you would get about 73.91%. Okay, now what we do is we create a graph that shows the conditional distribution for the age groups and the type of cell phones. So remember, we have three of them, three conditional distributions. So you're going to see actually 9 bars. So let me do this first one here. So the way this looks is that we're going to have age groups down here. And we would have the 18 to 34-year-olds. Then we would have the 35 to 54-year-olds. Then we would have the 55 plus. So for the 18 to 34-year-olds, you would have bars that go about 33% high, 41.4, and 25.9, or about 26%, we can say. So 3 bars over here. So about 32.69. And the next one would be a 41.69, so something like that. And about 25, or 20, a little below 26. Let's scale the percent on the vertical axis so it's easy to see. We'll go by 10 in this case. Now, what we also need is to distinguish each type of cell phone so the bar doesn't look the same. So what we can do is we can make a different shading for each one. We'll make the iPhones be shaded in, the Androids will be blank, and for the others, we can just do like slashes like this. And let's make sure to include a key so anybody reading this can understand it. So a key would be like, we would have a shaded bar for iPhones, open for Android, and then X's through it for other. Make sure you always include a key on your AP exam. You actually do get docked down if you don't have this, so keep that in mind. Now let's do one for the 35 to 54-year-olds. we'll have one about 27, the next one about 30, and the next one about 44, 43. 27. About 30. And about a little less than 44. Oops, that's not 44. iPhones would be shaded. Android, we're going to keep it clear. And the others, we're going to put X's. All right, and then for the last age group, we would have about 14.6%, 11.5%, and about 74%. So 14.6, something like that. 11.5, maybe like that. And a little less than 74. Shade the iPhone in, Android leaves blank. And for the other, I'll put X's. And now, see, with this graph, it's much easier to see like that if there's any relationship between cell phone ownership and age groups, and you could probably tell that there's a difference. It looks like that among the older people, that the majority of them tend to own other types of cell phones. Now, for the other groups, the middle age groups, and it's kind of a little roughly the same, but the other still is the most. However, for the young groups, it looks like the Androids are, the highest, and then followed by then the iPhone and the other. So it's actually the opposite of like the other of the big group, and so forth. So now again, since we're just getting some of the basic techniques of statistics, we're not going to have too much of a rigorous numerical way to define this. So we just keep it simple. We'll just say that the older you get, the less likely you are to use an iPhone, and the far more likely you are to use other types of cell phones. You are to other types of cell phones. All right, there you go.